I thought this was a really great path towards making our buildings better. I mean, we can make our mechanical systems more efficient. We can make our electrical systems more efficient. But if the building enclosure is not in step with those things, you're limited in what you can do.
Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered, and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. You can also check out our Reimagined Buildings YouTube channel for some great inspiration for both building new or renovating. In the meantime, here's this week's Passive House podcast. Kia ora koutou katoa. I'm Matthew Cutler-Welsh coming to you from Tamaki Makaurau here in Auckland on Māori Language Week, which is very exciting, and joined by Zach. How are you, Zach?
We're doing great. I'm here in Seattle, and school is back, and it's fall, and it's all good.
We're ramping up. Well, it's already ramped up. We're there. We're in election season. We have a general election coming up, probably about 5 weeks from the time that we're recording now. So there's a lot of people making wild promises about all sorts of things, and people pulling those promises apart at the moment, which is interesting. Paying close attention to what people are saying about housing, both new housing and also existing housing. For New Zealand, we're a little bit of an anomaly in that our building stock accounts for about 20% of our emissions instead of the global average of around 40%. But that is still a significant proportion, and it is also something that is relatively easy to do something about if we wanted to. So that's where we're putting pressure on all parties to either keep some of the commitments that are in place, or ideally make those commitments stronger to reducing the both operational carbon and embodied carbon, and also, of course, keep making houses warmer, drier, healthier, and build more of them, because we need to do all those things at once. So that's what we're working towards.
We're also in election season. Our election is about 65 weeks away.
Yeah.
and we're discussing the future of democracy and this
for the world.
So
yeah.
Anyway, I'm hopeful. Fingers crossed.
Well, as a segue to that, the US does have influence around the world, and today's guest, RDH, is a name that I heard probably 6-7 years ago now, just because of their prevalence in building science and what they do. And in fact, many of their former staff or certainly colleagues or friends from their team have done work here in New Zealand, and probably we owe some of the introduction of just the concept of building science to RDH and some of their team who have done work either directly or indirectly with people here. So great to be speaking to one of their team.
Absolutely.
Well, we'll get into that. So excited to start that interview. So, but before we do, let's say thanks to a few of our supporters.
Yeah, so a big shout out to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel, Minitaire, Partel, Rockwool North America, Stocorp, and Zola Windows. Thanks to our champion sponsors, Bewizo, Gradient, Icon Windows and Doors, Intelligent Membranes, PH Air Seal, Proseco, and Source 2050. And a big shout out to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority.
So tell us a little bit about how you came across Dave Fox.
We have been having conversations with RDH around some article writing that we're doing for the magazine, actually, and the focus on code. And RDH, as you mentioned, I mean, they've been a powerhouse for years and years in the space of high performance building and passive house, and have had a role in Massachusetts in helping to consult on the code development that's been going on there around Passive House, and also they've been active in Washington. So we have this interesting kind of comparison from Andrew Steingeiser, who is out of the Boston office of RDH, who we interviewed a while ago about what's been going on in code in Massachusetts, and now this interview with David Fox from the Seattle office about what's going on in Washington State code. So we dive into that and get a good update, and also an interesting kind of comparison, a little bit of a compare and contrast with the different approaches that code is taking in these two places. They're going to similar end games kind of, but the pathway is a little bit different. So please enjoy. Well, I'm very happy to have Dave Fox join us for the Passive House podcast. Dave, thanks for being here. So you are a senior project manager at RDH Building Science, and you work out of the Seattle office, which is in Wallingford, a neighborhood that I live in. I'm just like, my house is just a few blocks up the hill. Could you start by maybe telling us a little bit about the role you play there?
Senior project manager, as you mentioned. I split my time between passive house projects, energy related projects, as well as just building enclosure projects, helping just code compliant buildings do better with their building enclosure. There's a lot of buildings that are just code compliant, and I like to point out all of the things that people just ignore, and try to get those better and make our buildings more resilient, more durable, longer lasting, so we don't have issues with, water leakage, air leakage, all sorts of those things with our building enclosure. And again, just trying to push buildings to be more energy efficient and durable.
Well, and a great place to be doing that. I mean, RDH has been a leader in this space for many, many years. So you received your CPHC a few years ago. Yeah. Can you tell us about your pathway to that certification? What brought you to Passive House? It
was a few years pre-pandemic, which, just thinking back, lots of people in a tight, crowded space was an interesting thing. So what drew me to Passive House? I'm an outdoorsy person. I enjoy winter sports a lot. And just, seeing the changes over the years from when I was a kid to what I see now, it just kind of spurred me to want to take my knowledge, take my experience, and shift it a little bit and focus more on making things better rather than just, keeping up with the code, right? I wanted to take a step forward. I wanted to help buildings be here and be a catalyst for change with the climate and all of our energy use and everything. And I feel like the building enclosure was the right step towards that. I mean, the building enclosure really defines how much our energy our building loses to the outside environment, right? I mean, be it just thermal energy, also solar energy. I mean, there's so much just tied to the building enclosure that I thought this was a really great path towards making our buildings better. I mean, we can make our mechanical systems more efficient. We can make our electrical systems more efficient. But if the building enclosure is not in step with those things, you're just kind of, you're limited in what you can do. Yeah. So I wanted to take the CPHC class and start getting involved in passive house projects and hopefully pushing those forward across the nation. And supporting those projects.
Yeah. And was that FIAS or PHI? Which certification?
I did it through FIAS.
Yeah. Awesome.
Yeah, I did it through FIAS. Yeah, it was a great program. I had already been familiar with a lot of the thermal modeling softwares and WUFI and Therm and everything. So taking a step to learn WUFI passive and all the nuances with Passive House was a natural step.
Yeah. Well, also you studied at Penn State, right?
I did. Yeah. Right.
Which is has a really strong building science foundation in architecture and engineering,
Yeah. So my degree was the architectural engineering program at Penn State, and, learned all the different systems, everything from structural design, mechanical design, electrical design. I don't know that I could step into those fields today, but I at least know enough to understand what's going on in the mechanical design and electrical design realms. And it's I took a few building science classes, although I will say once I got out into the working world, it was a lot to learn.
Yeah.
It took
Sure.
took quite a few years to kind of really get up to speed. But it definitely left a good foundation for me to start that process.
Yeah. And when did you come out to Seattle?
2008 was my
Yeah.
first year out here. It was a great time. I did spend some time in Boston too. I did not work with Andrew, or any of our other folks in our RDH Seattle or Boston office at the time. I was working for a competing firm. RDH did not have a Boston office at the time, but then I came back to Seattle in 2015, 14, something like that. I've been here ever since and don't plan on leaving again.
Yeah. No, it's a great place. So you were here a little bit pre-wildfire smoke season.
Yes.
Like, it wasn't a thing.
It was not a thing back then.
Yeah.
You're right. Yeah. It was just glorious summers, and now it's glorious summers with a little bit of smoke.
Yeah. We've been fairly fortunate so far this year, knock on wood.
Yeah.
Well, thank you for that that kind of background. It's super interesting. So, and you mentioned Andrew. That's Andrew Steingeiser, and he's at the Massachusetts office of RDH Building Science, and he and I had an interview a few months ago about the code there, the code progress that's happening in Massachusetts, which is really exciting and kind of in many ways very formally tied to Passive House and Passive House certification and all that. There's also a lot of really exciting stuff happening in Washington State, perhaps less specifically around Passive House. So anyway, it's going to be really fun to, I think, explore the progress that's going on here with you and understand how it's different, where there are parallels and things. Maybe you could give us a bit of your lay of the land in terms of Passive House in Washington. Like, are you working on Passive House projects here? Are you seeing and noticing an uptick in Passive House specifically, or high performance building more generally in the state? We know that like in Massachusetts, there are tons of Passive House projects happening there now and on the books. What's the picture like here in Washington?
Yeah, so our code is not tied to Passive House, aside from the residential market. The residential market does have a path for energy code compliance through Passive House, and that's beneficial. There's not a path currently for multifamily buildings or commercial buildings to go and say, hey, we're complying with FIAS or PHI, and therefore we should comply with the energy code. So you still need to go through the energy code steps, even though going through one of those programs you're pretty much guaranteed to comply with the energy code. I'm working on quite a few Passive House projects, a few multifamily projects in Washington, a couple in Oregon, one in Idaho. We've got two that are kind of wrapping up certification, two multifamily projects, one in Marysville and one in Seattle.
Nice.
I'll say as far as new projects coming on board, there's one kind of sitting out there waiting to get started. And then we have a bunch of other feasibility studies. Interestingly enough, a lot of the feasibility studies that we've done for Passive House, looking at the building enclosure, the building form, mechanical systems, a lot of those unfortunately haven't gone Passive House, at least not as many as we would have liked to have seen, have not gone Passive House. They end up kind of sticking with just the building code. So it's good that our building code is heading in a good direction. It's heading towards Passive House, but it's definitely not quite there yet. So I'd love to see more Passive House projects out there, something that, has a little bit more. I would love to see things that have a little bit more building enclosure focus, and not just, hey, let's get a great efficient mechanical system, but hey, let's also reduce our energy use while we're reducing our mechanical system. So, I'm not seeing as many Passive House projects as I would like, but it's great to see markets like Boston. I think they're kind of proving, the way that you can, Massachusetts, Pennsylvania, the ways that you can introduce Passive House and incentivize it and get more of those buildings built. So hopefully we see a little bit more of that. Washington seems to be focused a little bit currently on the existing building stock and things like that. So we'll see where things head. Our building code is heading in the right direction. It's just not quite there yet. And like you said, not specifically tied to a Passive House standard.
And let's dive into that a little bit deeper. You mentioned that the code is moving toward passive house, and I think what you're alluding to is maybe was it 10 years ago, maybe a little bit longer ago, the Washington State Legislature passed a commitment that new buildings in 2030, 2031 should be 70% more efficient than new buildings were in 2006. So that it's a 2006 code baseline. And so when you look at those numbers and the EUIs of those buildings, 70% better than 2006 is roughly in the passive house category. It's very high performance. So the question is the devil's in the details. How do we actually get there? There is this exciting piece in the new code where Washington is going to be requiring heat pumps for heating and domestic hot water. The Building Industry Association of Washington succeeded at delaying the implementation of this new code, but only by 120 days. So in late October, this is going to become code. So can you tell us a little bit more about the details of that move? I think it's the first time in the country. What buildings that applies to, and do you see that? I mean, will this be a big catalyst for change, you think, here and then maybe elsewhere?
I hope it's. I mean, I'm really excited for it. I think it's a great step in decarbonizing our end use of the building and heating loads and things like that. It's more. I don't think it's all buildings. I think it's mostly, if I recall correctly, I think it's commercial buildings and then large multifamily buildings. I think other buildings kind of get away from it at this point, but and then you can still use gas for cooking. You don't have to use electric for cooking. But I think it's a great step, and I think at least the market here doesn't seem there's just not as much experience with heat pumps and how they can be used. They're still not getting around the fact that we can use a heat pump year round here and heat our buildings without problem. There just seems to be this feeling that we need gas, right? When it gets cold, we need gas. And I'm hoping that this shift will start to educate, our not just designers that aren't in the know, but our installers and everybody that we can do this. We can electrify. We can have electric heat with heat pumps in this climate and make it work. I'm looking forward to it for sure. I switched over my house to a heat pump and I haven't looked back. So
I'm yet to make that change, but I'm eager to do so. And I think that one of the big things that this will do is also be a major market signal to the industry that we're making this shift, and hopefully we'll have more and more people who know how and are expert at installing heat pumps.
Yeah, right now, we've had a bunch of projects. I had one recently that was in the feasibility stage, and they were just having a really hard time finding a contractor who would install and supply the heat pump units that we were looking at. And that was a big barrier for them. I mean, it was a cost, it was a schedule implication. There was a lot of implications to using these heat pumps. And to get more of them in the market, to get more contractors on board, to get all this, this whole infrastructure set up behind it, I think is going to be really important.
Yeah. Well, and heat pumps also, I mean, they're just going to make our lives better in this region. I mean, this is a region that never needed cooling before, but now we need active cooling in the summer, especially during, if we have a wildfire event and we are closing up the windows during the evenings when we would typically be getting some fresh, nighttime cooling there. So I think there are a lot of just like no-brainer benefits to this. So it's cool. It is cool to see it, and I know it's taken political leadership to make it happen, and so it's great to see that it's coming down the pike very soon. So pivoting away a little bit from heat pumps and more to the envelope improvements and the kind of understanding the building as a system and all the ways that we dial in the different elements of the system to create high performance buildings. In what ways are the code improvements that have happened either in this cycle or the cycle before resonant or in parallel with passive house principles and these more ambitious targets for energy performance?
Yeah, I mean, one of the biggest things that Washington State and the city of Seattle have done is targeting air leakage and getting airtight buildings. That for the longest time, that you had to have airtight assemblies, you had to have airtight materials in your buildings, but there was nothing really holding you accountable for making an airtight building. And if you had, egregious air leakage, it didn't really matter. So we started years ago with just, hey, you got to test your building, and
Right.
here's the target. If you exceed your target, make some effort to try to seal things up, and then we're good. And the newest code that's going to come out is going to have a little bit more bite to it. It's going to require you to actually go back and fix your building and get to the air leakage. It's I believe the new code is 0.25 CFM per square foot. So still a little ways away from passive house, but that's one of the huge things with passive house, right? Is making an airtight building enclosure so that we can control the air that comes in and out of our building, and make sure that it's clean, make sure that it's conditioned, and rather than uncontrolled air leakage. So I think that's a great step for the state of Washington and for the city of Seattle to keep pushing the envelope with air tightness. Other things that that our code is doing, it seems to be we're tightening the screws on the efficiency of all of our assemblies, right? So the windows are getting, the window requirements are going to get a little bit tighter this next code cycle. The one thing that I see as lacking, kind of diverging from passive house, is the building form doesn't seem to be taken into consideration, right? You can design the wackiest form you want, and as long as you meet these, this effective U value or this R value for your wall assemblies, you're good, right? So passive house and other codes in the area, BC, for example, they're looking at the form factor for your building plays an important role in your overall energy use. So I think that's one area that Washington State and Seattle could probably improve a bit to getting closer to the passive house standard, is taking into consideration how the building form, and how much enclosure area you really have for the square footage that you're enclosing. I've looked at quite a few different projects that have had some funky shapes, and it's like, now this really wouldn't resonate. This doesn't resonate with passive house, and you could throw some extra R value at these wall assemblies to make it better, but you're just not going to get there. So I think that's one area that I'd love to see the code improve. And also the code is now starting to get a little bit more serious with thermal bridging. So the city of Seattle has a little bit of language in there as far as looking at window placement within wall assemblies and things like that. You can't, they're trying to rein in the thermal bridging that happens around window assemblies and pushing them too far out. So you have these egregious thermal bridges around windows. It's still doesn't have too much teeth. It's still not quite there. I don't think it's not as aggressive as, say, BC, where they want you to really look at those in more detail, potentially, with modeling or something like that. We're just not quite there yet, but hopefully we'll move in that direction soon.
Yeah. That point about the building form, it gets at that question of performance-based code a little bit, right? Because one of the reasons that we pay attention to building form is we're not just looking at kind of a little bit more of the prescriptive, like, okay, this is what your wall needs to do, but actually what's going on with the whole building, and is the thermal energy demand intensity and the overall energy use intensity actually lower. So do you see on the horizon the Washington State code kind of grappling with that performance question?
Well, I hope so, because we have the clean buildings standard out now.
Good point.
Where existing buildings and even new construction buildings that are built today will eventually have to comply with this as well.
Right.
If your energy use is too high, you're going to have to go back and make some changes to reduce your energy use. So I mean, I hope so, because you could probably build something right now that's code compliant that might not meet the clean building standard.
Right.
I could just envision a building, with all these jogs and ins and outs that just wouldn't meet it because there's just too much energy loss. So I hope it's something that they kind of circle back and think about, overall building performance, because we're designing these buildings to code, but like I said, we also need to think about, once that building is occupied, now they need to meet this clean building standard. Because once it's occupied, it now becomes an existing building and it's part of that program. So kind of thinking forward for our buildings that are in design right now, what are they going to need to do to comply with this program once they are occupied? So I hope the code circles back a bit.
Yeah. Yeah, and the clean building performance standard, just for folks, is, I think that was passed just a couple of years ago, a major milestone, because it requires existing buildings to hit energy use intensity targets. Existing buildings, I think it's 50,000 square feet or larger, and it'll start, I think, in 2026 and start to encompass more and more buildings. So that's excellent. And so I think you've touched on this a little bit. You mentioned British Columbia. You've mentioned Massachusetts a bit. But are there any other comparisons or contrasting that you want to draw between what's happening with the new code and here and what's going on in those two jurisdictions?
I really like the way that BC has set things up with their step code. They're following the TEDI and the UE, and looking at overall building performance, and incrementally stepping that up, depending on where you're located and different things. I like that. I think that that's probably closer to a passive house model than where Washington State's current code is. Washington State's code is doing other things, though. Like there's, we have different energy credits that you have to obtain beyond just complying with, there's the prescriptive outline for the energy code, but then we also have to comply with these energy credits. And one of the credits is enhanced building enclosure performance, and then the other one is enhanced air tightness. But then there's a wealth of other ones, right? And again, it's kind of this focus on the mechanical systems rather than the focus on the enclosure. And I feel like the BC model focuses, or at least it rewards focus on the building enclosure a little bit more than the Washington State code does. So I think there's room to grow, but I think we're all heading in the right direction.
Yeah. Now, you clearly have this a building enclosure bent, and it's one that I share. And there is this there is an interesting dynamic a little bit in Washington State, because I think sometimes there's this assumption that because we have hydro, we have clean electricity, ignoring the fact that we're actually part of this larger region where the average the carbon intensity of our electricity is basically on par with burning natural gas. So there can be, then the conclusion can be drawn, if that's how if you think of our electricity as clean, that who cares about energy efficiency, or is that really important? Could you talk a little bit about that? Like why do you see energy efficiency as critical to our carbon goals in buildings, specifically in Washington State?
Well, I mean, the grid's, we're constantly cleaning up the grid.
Yeah,
right? It's always improving. There's lots of strides being made on that side of things, and we know that we are lucky in this area in particular. I mean, I look at my energy supply mix, and it's nearly all hydroelectric. But the more hydroelectric that I use, the less hydroelectric can go somewhere else.
Yeah.
So I think maintaining efficient systems is still really important, regardless of our grid, because we can help supply that to places that that have a dirtier grid. And like you said, we're all part of this big connected system, and if Seattle can reduce its impact, then that can offset other places. So yeah, I mean, I do think it's important. I'm not going to say that I'm a grid expert here. It's definitely not my realm, but I think we're all just part of a big picture, and if we can all do our part, it'll help. And even if only a few people are doing their part, at least we can offset the other folks.
Well, I think that is a great place to close here. And I just want to thank you for the work that you're doing to do your part, and the role that RDH is playing in all this. It's been great to connect with you today.
And that was Dave Fox of RDH, based in Seattle, close to you, Zach.
Literally down the street.
The first thing that struck me from that conversation was the fact that you mentioned that Penn State is really strong in architectural engineering.
Yeah.
And I'm excited that that's a thing. And it strikes. And I mentioned at the top of the show about the influence that RDH has had. It's certainly for me introducing the concept of building science, and I think that's something that is potentially taken for granted where building science courses, building science as a profession does exist. We do have a course in building science here in New Zealand. I think there's a little bit of it in Australia, but it's very much you either become an architect or you become an engineer, and there's so much need, as Dave has clearly experienced, for this sort of middle ground of architectural engineering where you're working with architects but also really understanding and implementing the building science. So it's really encouraging that companies like RDH have been so successful filling that niche, and I hope that spreads, because I think we desperately need it in this part of the world.
Yeah, well, that's interesting. 'Cause, I mean, the Penn State connection, I first became aware of how what a kind of center of academic thinking and kind of praxis around building science that was there. I first became aware of that through Brandon Nicholson, who we heard about in the previous episode. And Brandon, when he moved to Pittsburgh, got connected to folks there, and the Penn State kind of center there is also involved in this international network around building science and kind of centers of excellence that the United Nations has been involved with and stuff, and this high performance buildings program there. So I think that there is actually a real potential for there being a connection between the building science stuff that's happening at Penn State and maybe some developments in New Zealand.
Yeah,
hopefully. Yeah, could happen.
The other thing that struck me was you mentioned about the Washington State changes to the code that require or will require a 70% reduction or 70% better building than the 2006 standard, and that is to hopefully come into force by 2030. So by 2030, is that right? By 2030, buildings have to be 70% better than they would have been in 2006.
That's what the state legislature committed to, about 10 years ago or something like that. Yeah. Whether it is actually translated in the real improvements in code has to do with how well we do every 3 years with the code cycle.
Sure.
So it's it could fall short, but yes, that is the goal. And it's basic when you do the math, that when you look at the energy use intensity of buildings that are 70% better than new buildings were at 2006, it's past fast levels. So
right.
It's definitely ambitious, which is great.
Yeah. So the thing that struck me most about that was the fact that it was introduced 10 years ago, and why I think that's important and relevant to me in my world is that I am frustrated, and a lot of my friends and colleagues are frustrated about the pace of change that we need to get stuff done. And I also need to appreciate that it takes time to change the industry. So it's encouraging at one level to know that these changes are taking place, but it's also informative to know that the seeds of that change were planted quite a while ago. And sometimes it just does take that time. Now, hopefully we can accelerate that, hence the Passive House Accelerator. We're trying to increase the speed of that change. But I think it's important for us to realise that we do need to be a little bit strategic sometimes to say, this is our end goal by 2030. What do we have to do between now and then to get to that point? And 2030 is approaching now, and I'm talking to large developers who are working on projects that have a sort of 3 to 5 year construction horizon. So those times are real. It's much more real than the lofty sort of 2050 goals. So point being, introducing the early stages of policy change, I think, is really important with a long game in mind, which we're starting to see the fruits of now in jurisdictions like yours. Now, you say there's still a risk that things could hopefully not totally fall apart, but they might get eroded, they might get slightly diluted or changed, but at least they're on the right pathway to that change. And that includes things like electrification and requirements for air tightness. The air tightness is an interesting one because you mentioned the air leakage targets that are in place in Washington State. I think 0.25 cubic feet per meter. I struggle.
Per minute. Yeah, CFM, so cubic feet per minute at 50 pascals of pressure per square foot of enclosure. I believe is the correct unit.
Yeah. So I have to look that up. That's around 7 litres per minute in metric terms. If we
which is useless.
It's kind of useless.
To me, I should say.
Cubic feet per minute equates to about 7 litres per minute. That's about what we would 7 litres per minute is about that's a pretty hefty flow rate for a ventilation system. So it's not exactly tight, right. and I think what's the requirement for passive?
Yeah, the right, because FIAS uses that the permeance basically of the envelope in its airtightness measure, and the FIAS is typically 0.06 CFM at 50 pascals per square foot of enclosure.
Right.
So 0.06 compared to 0.25. So we're talking that it's 4 times looser, the Washington standard compared to FIAS standard for air tightness.
Right.
So I mean, it's definitely in the right direction, and it's good that we're measuring and stuff. But there's lots of room for improvement, clearly.
Yeah, I'm just trying to do this conversion on the fly here. So 7 litres per minute would that's about 0.42 cubic meters per hour. Again, you then have to convert that to cubic meters per square meter of envelope area, but you get the point. There's 2 points really. One is that there's a standard. There's a requirement to do air tightness testing. That is significant because we don't have that yet, and I think that's really, really key that we're seeing a lot more jurisdictions around the world where even just doing a blower door test is required. So that's the first point. The second point is that there is, in some of those places, like Washington State, there are these targets in place now. They may fall short of Passive House, but at least there is a goalpost. So there's something that people know that they have to hit. I think that's really encouraging. Dave talked about form factor, which I thought was also really interesting, and that obviously one of his frustrations as a architectural engineer, seeing crazy shaped buildings and knowing that that's a problem for overall performance. I'm not sure. I mean, I guess there are ways that you could codify that by having metrics around the simplicity of the form factor, but I thought it was interesting that he obviously notices enough for it to be a consideration, and wishing that designers would appreciate the impact that form factor has on buildings.
So important.
And then the final one was around thermal bridge requirements. And I found this interesting because this is also something that we're just introducing here and talking about the placement of windows and the fact that if you invest in a really good window frame, a thermally broken one, thermally efficient window frame, there's no point in having it hanging out on the outside of the building, because then you're just going to reintroduce a thermal bridge through that envelope. So bringing the windows back in line with the insulation is really key. And there are some issues around weather tightness that people get very anxious about doing that, but it's so important for the overall thermal performance of the building. So it's really interesting for me hearing about these concepts being discussed and also a lot of them having been solved already that we're grappling with here. And then just finally, you mentioned about the clean building performance targets. I think this is really, really exciting. So can you just give us an outline very quickly what that is in your area?
Well, essentially, it's the idea that existing buildings need to have a certain level of energy performance, and that if they're not, there are repercussions. And so there's a similar thing going on with Local Law 97 in New York City as well. Seattle is also considering its own version of this, but it's the first step in requiring that all buildings have some sort of basic level of energy performance, and that there will be consequences if they don't make those requirements. So right now it's for larger buildings. So it's certainly nowhere near close to all buildings in Washington State. But it's a really, really important step, and starts also then we start asking the question, what is the appropriate energy use intensity for existing buildings, and really starting to dial into important questions and answers around how much energy and therefore how much carbon our buildings are emitting.
Yeah, nice. Great stuff, and always a pleasure to hear from anyone really at RDH. The great work that they do.
Yeah, no kidding. Yeah,
and of course, really appreciate their support as well. Great. What do we got coming up, Zach?
Yeah, so we're back in the thick of it with programming. So I'm on Passive House Accelerator Live, which is Wednesday for us here, for Thursday for you. This coming week, we have Schools Active Learning Passive House, and this is a presentation by Dan Swab and Brendan Connolly of Methuen and David Mead of PAE. This is a passive house school in Seattle that I've had a chance to tour. We did a little video about it. Really beautiful project, and super great, smart presenters who will be telling us all about that and why. One of the things is just why the community decided to do passive house. That was a great story around the parents and this idea of setting an example and showing an example for the kids. And then on Thursday, so Friday your time, we have a Passive House Component Spotlight. We're going to be joined by Karine Gala and Dan Canova of StoCorp, and they're going to be presenting combining passive house performance and aesthetic versatility. So really looking forward to that. And then in just a couple weeks, we have the Passive House Network Conference in Denver, Colorado, in the beginning of October. And then in November, we're going to have FIASCon in Houston. So we're kicking off a busy fall of lots of cool passive house programming.
Awesome, lots and lots going on. Great to be back in the thick of it, as you say. Awesome.
Yes.
All right. We'll be back again next week.
Thanks, Matthew.
Thank you. We'll check in again then. Look forward to seeing you.